Examples of possible questions in arithmetic sequence are showcased in this video. Check them out here in Mathematics of Engineering. The first problem provides the elements 12, 15, 18, and 21 as the pattern, and the tasks are to find the 18th and 19th terms, also the summation of 20 and 21 terms, then determine the explicit and recursive formulas for the pattern. In arithmetic sequences, there are only two standard formulas provided. One is used when determining the nth term. The formula is a sub n as equal to the initial term plus the common difference times n minus 1. For arithmetic series, the formula of f sub n is half of n times the initial and final terms added together. In cases when the final term is not provided, s sub n can be derived using the previous nth term equation to give half of n times twice of the initial term plus the difference times n minus 1. The first requirement is to determine the 18th term. Using the nth term equation, we can compute for the required by plugging the initial term of 12, the difference which is computed as 15 minus 12, or 18 minus 15, giving 3. N for the required is 18. Place everything in the equation and have a sub 18 as 12 plus 3 of 18 minus 1. This is simplified as 12 plus 3 times 17, which gives the 18th term as 63. The other term to determine is A19, and just by changing n into 19, A19 can be computed as 12 plus thrice of 19 minus 1. This is simplified as 12 plus 3 times 18, giving 66. For the summation of the first 20 terms, there are two equations which we can use. However, since we have no idea what the final term is valued at, we would be using the second equation. Taking n as 20, s sub 20 becomes 20 over 2 times twice of 12 plus 3 times 20 minus 1. Simplify the equation and have 10 times 24 plus thrice of 19. That can be evaluated as 810. For s of 21, n is taken as 21, making s sub 21 as 21 over 2 times twice of 12 plus thrice of 21 minus 1. This is simplified as 21 halves times 24 plus 3 times 20, which gives 882. Next is the explicit formula of the pattern, which is initially solved as placing the difference with n, then adjusting it to fit the initial term. Knowing that the difference is 3, we can compute for a sub 1 as 3n, which is 3 times 1, making 3. This is far from a sub 1, which is 12. So to compensate for the missing element, we have to add 9 to the formula, making a sub n as 3n plus 9. The last requirement is to identify the recursive formula. This is the repeating formula of a pattern with the standard form of solving a sub n by taking the previous term and adding the difference. Knowing d as 3, we can simply plug it in the formula and have a sub n as a sub n minus 1 plus the difference of 3. The second problem provides a sub 4 as 2x plus b, and the difference is negative half of x plus 3b. The requirements are 10th and 11th terms and the summation of the first 11 and 12 terms of the pattern. Then for the explicit and recursive formula, just the same. Let's figure out the 10th term first. Having a sub 4 as 2x plus b, and d as negative half of x plus 3b, then n is 10, we use them in the standard form of a sub 10 as equal to the fourth term plus the common difference times 10 minus 4. These values are the indices of the terms. Plug the given parameters to have 2x plus b, then 6 times negative half of x plus 3b. Distribute the common difference 6 among the terms and get 2x plus b plus negative 3x plus 18b. Collect similar terms to end with a sub 10 as negative x plus 19b. A sub 11, on the other hand, uses n equal to 11. The formula will be changed a little into a sub 4 plus d times 11 minus 4. So by substituting the given parameters, we get 2x plus b plus 7 times the common difference. Then distribute 7 among the terms of the binomial and arrive at 2x plus b plus negative 7 halves of x plus 21b. Collect similar terms again and get negative 5 halves of x plus 22b. For the summation of the first 11 terms, we can use the two formulas provided. But with the same case of not knowing what the final term is, we should just focus on using the second equation. With n as 11, the formula turns out as 11 halves of twice of a1 plus d, which is negative half of x plus 3b, times n minus 1, which is 11 minus 1. S11 is then 11 halves of twice of a sub 1 plus 10 with a common difference. By distributing 10, the equation turns into 11 halves of twice of a sub 1 plus negative 5x plus 30b. With the equation already simplified, all we needed to look for is the initial term a sub 1. Use the standard nth term formula and get a sub 4 as a sub 1 plus the common difference times 4 minus 1. Plug the given parameters and get 2x plus b is equal to a sub 1 plus 3 times the common difference. Distribute 3 among the terms to have 2x plus b as a sub 1 plus negative 3 halves of x plus 9b. Now isolate a sub 1 by transposing the other terms to the other side to have a sub 1 as 2x plus 3 halves of x plus b minus 9b, which when simplified gives 7 halves of x minus 8b. Getting back to S sub 11, after learning what a sub 1 is, we get 11 halves of the quantity which includes twice of 7 halves of x minus 8b, and the quantity of negative 5x plus 30b. Distribute 2 and the equation is transformed as 11 halves of 7x minus 16b plus negative 5x plus 30b. Collect similar terms in the quantity to have 2x plus 14b. So S11 turns out as 11x plus 77b. Now it is easier to determine S12 using n as 12. The formula would turn as 12 halves of twice of a sub 1 plus the common difference times 12 minus 1. Work with 12 minus 1 and make the equation 12 halves of twice of a sub 1 plus 11 of negative half of x plus 3b. Distribute 11 to the binomial terms and get 12 halves of twice of a sub 1 plus negative 11 halves of x plus 33b. Now all we need to plug in is a sub 1, which was solved earlier as 7 halves of x minus 8b. Plug in a sub 1 into the S12 equation to get 6 times twice of 7 halves of x minus 8b plus negative 11 halves of x plus 33b. Again, distribute 2 to have 6 by 7x minus 16b with negative 11 halves of x plus 33b. From here, collect similar terms to get 6 of 3 halves of x plus 17b, which can be reduced as 9x plus 102b. For the explicit formula, the n term is in terms of n, with a difference. So, a sub 1 uses n as 1 and becomes negative half of x plus 3b multiplied by 1. This shows a sub 1 as just the difference, and it is obviously not the same with the computed a sub 1 earlier. So adjust it by adding positive 8 halves of x minus 11b. So a sub n for the pattern is the quantity of negative half of x plus 3b multiplied by n plus 8 halves of x minus 11b, which can be reduced to negative half of x plus 3b multiplied by n plus 4x minus 11b. Last is the recursive formula, which is just adding the common difference to the term a sub n minus 1. So a sub n is a sub n less 1 minus half of x plus 3b. Problem 3 has the initial term as x plus y, and the fourth term as half of x plus 3/5 of y. We are to look for the two arithmetic means. Having two terms available, determine the common difference using the n term formula. That's a sub 4 as equal to the initial term plus the common difference times 4 less 1. Place the terms and get half of x plus 3/5 of y as equal to x plus y plus 3d. Put together all the x's and y's to isolate d and have 3d as equal to half of x minus x plus 3/5 of y minus y, which can be simplified as 3d equal to negative half of x minus 2/5 of y. Take d by dividing everything by 3 to have negative 1/6 of x minus 2/15 of y. Through the recursive formula, a sub 2 is just the previous term plus the common difference, that is x plus y, with the difference negative 1/6 of x minus 2/15 of y, and get a sub 2 as 5/6 of x plus 13/15 of y. A sub 3 is also a sub 2 plus d, that is 5/6 of x plus 13/15 of y plus negative 1/6 of x minus 2/15 of y, to have a sub 3 as 4/6 of x plus 11/15 of y. This can also be reduced as 2/3 of x plus 11/15 of y. Another arithmetic mean problem has a sub 1 as x plus y and a sub 4 as 7/2 of x with 11/5 of y. We are still to look for a sub 2 and a sub 3. First is to look for the common difference using the nth term formula. That would have the equation 7/2 of x plus 11/5 of y as equal to x plus y plus 3d. Move the x and y to the other side and isolate 3d as 7/2 of x minus x plus 11/5 of y minus y. Simplify the terms and get 3d as 5/2 of x and 6/5 of y. Again, divide everything by 3 to get d as 5/6 of x and 6/15 of y, which can be reduced to 5/6 of x plus 2/5 of y. Learning the value of the common difference, use recursive formula to look for a2, which is just a sub 1 plus d. That would be x plus y plus 5/6 of x and 2/5 of y. Simplify the terms to get 11/6 of x plus 7/5 of y. A sub 3 is also solved as a sub 2 plus d, or 11/6 of x plus 7/5 of y plus 5/6 of x with 2/5 of y, to get 16/6 of x plus 9/5 of y, which can then be reduced as 8/3 of x plus 9/5 of y.